Yes, student, we have checked earlier that acids are of two types: organic acid, organic acid. Organic acid consists what? Covalent bond. Covalent bond. These acids are weak in nature. It is because the dissociation of covalent bond is quite difficult. And the second type of acid are called what? Mineral acids. Okay. These acids ionize almost completely. Okay. Almost what? Completely. Therefore, these acids are termed as what? Strong acids. Okay. Now, strong acid we can deal many type of strong acid, like if you say HX acid, this is called hydrohaloic acid. Hydrohaloic acid. Actually, the X stands for halogen, therefore it is called hydrohaloic acid. Now, how many type of hydrohaloic acids are possible? So, this is possible as HF, this is possible as HCl, possible as HBr, and possible as HI. That is what? That is simply the X is replaced by F, Cl, Br, and I. Okay. Now how to discuss okay, their strength. So we know that acids are those which can release what, beta? Which can release what? H cation in aqueous solution. What? H cation in aqueous solution. In aqueous solution. Is that it? So the strength of acid depends on how easily okay, a molecule can release H cation. Okay, so one which can easily release H cation, one which can easily release H cation, H cation will be what? More acidic. Will be more acidic. Okay, that means what? That means now from HF, HCl, HBr, and HI, we have to discuss which can release H cation more easily. Okay, but to find the answer, we have to see the factor which affects the releasing of H cation. Therefore, we can see the content. Release of H cation depends on two factors. Okay, which are these two factors? First one, nature of bonding. Okay, and what? Polarity. Nature of bonding and polarity. Getting? In HX, F is most electronegative, hence HF acid is most polar. Okay, so will be most acidic. What? Acidic. Why? It is because it can easily release what? H cation due to large polarity between HF, that is in HF molecule. But student, one more factor is there, The second factor is what? Bond dissociation enthalpy. Bond dissociation what? Enthalpy. Enthalpy. Now you know that the bond dissociation enthalpy depends on what? It depends on what? Bond length. Depends on bond length. Okay. In HI molecule, okay, bond length is large due to larger size of what? I. Due to larger size of I, hence bond dissociation enthalpy is what? Lowest. So HI can easily release what? H cation. Can easily release H cation. Okay, and this factor dominate over first factor. Why it is? Because the bond dissociation enthalpy, if it is very low, then there is easy to break down the bond. As easy to break down the bond, more easy to release what? H cation. One more factor actually also work here. You know that being HF is most polar, therefore HF molecule can form hydrogen bond with another HF molecule. And if it will form hydrogen bond with another HF molecule, then there will be very difficult to release H cation in the case of HF. And therefore, the order of acidic strength will be, the HI will be most acidic, then HBr, then HCl, and then HF. So, although HF is most polar, but other two factors, which two factors? Bond dissociation enthalpy and the nature of bond, that is what? Intermolecular attraction force, it forms hydrogen bond. Student, we know that moving down the group, electronegativity decreases, therefore polarity decreases, thus HI is unable to form hydrogen bond. Moreover, its bond dissociation enthalpy is very low, therefore the strength is in increasing order. We can say it is what? Increasing order of strength. Increasing order of strength. Okay, so this is what? Very important question.